Hello, and welcome to Applied Mathematics for Business, CQMS 110. I am Dr. Pauline Fu. In this video, we'll talk about geometric series. Topics include summation notation, arithmetic and geometric sequences, finite geometric sequences, applications. So first, summation notation. If you want to add a number, for example, 1 plus 2 plus 3 plus 4, okay, until 100. If you want to do this, you can use mathematics summation, sigma, okay, is the summation, okay. So sigma n from 1 to 100 equal to this one here. So this sigma is the summation notation, okay. Let's introduce some terminology first. What is a sequence? A sequence is an ordered list of numbers, each of which is said to be the term of the sequence. For example, I give you a list, 1, 2, 3, 4, until 100. This is a sequence because this is an ordered list of numbers, and each number is a term, term 1, term 2, term 3, etc. Okay. Arithmetic sequence is a set of numbers in which each number of the first can be obtained from the preceding one by adding to it a fixed number that is called common difference. Again, this sequence is an arithmetic sequence, okay? So when you are given the first number 1, okay, the common difference in this example is 1. If you add 1 to the first number, you get 2. Add this common difference to the second number, you get 3. And add common difference 1 to the third number, you get 4, etc. Okay. In arithmetic sequence, again, I take the previous example, 1, 2, 3 until 100. This is an example of arithmetic sequence. An represents any term in this sequence. For example, the first number is A1, the second is A2. Okay. So generally speaking, you have AN. After AN, you have AN plus 1. Okay, then AN plus 2. So you understand the notation of AN. It is a just general term for this sequence. Okay. A1 always represents the first number in the sequence. Okay, and D, common difference. Okay, in this sequence, we said common difference is 1. Okay, so let's verify this formula. For example, what is A4? Okay, based on this formula, A4 equal to A1 plus N is 4. 4 minus 1 multiplied by D. D in this example is 1. Okay, D equal to 1. Let's continue. A4 equal to A1 plus 3D. D is 1, so A1 plus 3. And A1 is the first item. It is 1 plus 3 equal to 4. So A4 equal to 4, that's correct. The next sequence number in the sequence is 4. Okay. If you want to add all the terms together, this is the sum of n terms, Sn. Okay, for example, how many number in this sequence? 100. So n equal to 100. So you want to add 100 number together. Okay, plug in the formula, n equal to 100. Okay. This an represents A100 and plus A1 and equal to 50 bracket 100. And how do I get 100? You use this formula to get 100. Okay, so A100 equal to A1, A1 is 1 plus n minus 1, n is 100, 99 times d, d is 1. So 100 equal to 100 equal to 100. Okay, so 100 plus A1, A1 is 1. So the result is 50 multiplied by 101. And the result is 50, and then 0. And then, so 101. 101 multiplied by 50. And the result is 50, 50. Okay, 50, 50. Okay. So this is arithmetic sequences. Geometric sequences. So we start from an example. If I give you the sequence 2 and 4 and 8 and 16, 32, and you noticed in this sequence, if I give you the first number, you multiply by 2, get the second number. Second number multiplied by 2, get the third number, etc. Okay, so the common number is equal to 2. Each time you multiply by 2, you get the next number. Okay, and we call this 2 is a common ratio R. R is common ratio. Okay, and we call the first number is A1, second number A2. Generally, and we call the general term is AN. Okay, before AN, you have a number AN minus 1. After AN, you have a number AN plus 1. And what is the relationship between two consecutive numbers? It is here, AN equal to R times the previous number. And AN also equal to the first number A1 multiply R raised to power N minus 1. For example, in this sequence, in this example, if I want to ask you, what is A4? You use this formula, A4 equal to A1 multiplied by R. R is 2, raised to power N minus 1, N is 4, so 3. And A1 is 2, so 2 multiply 2 raised to power 3, and that is 16. A4 is here, A4. Okay. If you want to add all the geometric number together, that is the sum of n terms formula. So for example, if you want to add this together, Okay. So how many terms? 1, 2, 3, 4, 5. You have 5 terms. So F5 equal to A1. A1 equal to 2 times 1 minus R. R equal to 2. Raised to power N. N equal to 5. Okay. In this example. So 2 raised to power 5. Okay. Divided by 1 minus R and equal 2 multiplied by 1 minus 2 raised to power 5, 32, divided by negative 1. Okay. So this part, so negative 31 times 2 becomes negative 62. Okay, divided by negative 1. Negative 1, the final result, 62. So you can verify, you add all these numbers together, should be equal to 62. Infinite geometric series. Sorry. If you have a geometric series with common ratio smaller than 1, okay, so for example, you have 2. Suppose common ratio is 2, not 2, common ratio is 1 over 2, okay, so that it satisfies smaller than 1. Each time you multiply this ratio to the previous number, so the next number would be 1. So 1 multiplied by 1 over 2, get 1 over 2. Each time you multiply 1 over 2, you get the next number. So this is the next number. The next number, each time you multiply by 1 over 2 of previous number. Okay, and suppose this sequence goes forever. Okay, and now you want to add all these terms together. You want to add them all. And this is the infinite geometric series. You use this formula. So S equal to this. So plug in the formula, S equal to A1. A1 is 2. 1 minus R. R is 1 over 2. Okay. So this is a simplify. 1 minus 1 over 2 is 1 over 2. So the result is 4. Okay. So this result is 4. Why we emphasize common ratio smaller than 1? If you have common ratio greater than 1, for example, the previous example we gave you this number, okay? And in this example, R equal to 2. Suppose this sequence goes forever. So R equal to 2. And if you try to add all these numbers together, guess what? Okay, the result goes to infinity. Okay, very, very big number, infinity. That's why we emphasize R equal to 1, smaller than 1 in infinite geometry series if you want to do the addition. All right, we introduced the basic concept of arithmetic and geometric series. Now let's look at an example. By the way, what is the difference between series and sequence? A sequence is, for example, you have a common separate the term, that is the sequence, okay? A series means you want to do the addition of all of these numbers. This is a series. That is the difference, okay? Okay, loan payment. A person borrowed 3,600 and agreed to repay the loan in monthly installment over 3 years. The agreement is to pay 1% of the unpaid balance each month for using the money and 100 each month to reduce the loan. What is the total cost of loan over 3 years? So let's draw a timeline. 3 years have, so this is now 3 years have 36 months. Okay, 36 months. Okay. So a person borrowed 3,600, and each month he or she will pay 100 each month. So next month the balance becomes 3,500. The month after becomes 3,400, etc. Okay. But the other condition is you have to pay 1% of the unpaid balance each month. Okay. So after each month, okay, so 1%. So the 1% for the first balance, 3,600 is this one. Okay. And then for the next balance, you have 3,500, 1% applied, etc., etc. Okay. So the total cost of the loan would be, add all these numbers together, 1 plus 2 plus 3 plus 34, 35, and 36. That is the total cost. Okay. And this is a arithmetic series. This is arithmetic series. And remember, if you want to add this, so what you do, equal to how many terms? 36. Okay. And then if you look at the formula here, just show you the formula. See, arithmetic, okay? Last term plus first term. Okay. Oops. So equal to how many items? 36. Okay. And the first term plus last term. Okay. So equal to 18 multiplied by 37. That is the total cost. Okay. So let me see my calculator. 18 multiplied by 37. Okay, I get 666. The next example. The government has decided on a tax rebate program to stimulate the economy. Suppose that you receive 1,200 and you spend 80% of this. And each of the person who receive what you spend also spend 80% of what they receive. and this process continues without end. According to multiplier principle in economics, the effect of your 1,200 tax rebate on the economy is multiplied many times. What is the total amount spent if the process continues as indicated? So this one is an infinite geometric series because this process continues without end, means infinite. And the first item is A1. Okay, you spend 80% of $1,200. Okay, and R is 0.8, 80%. So use the formula. Okay, all the money spent, you add them all. Okay, equal to A1 over 1 minus R, and you figure out this is the total money. Okay. So we would expect the 1,200 tax rebate will result in about 4,800 spending. Okay. So in summary, what we did in this lecture, we introduced the summation notation, sigma. Okay. So if sigma x squared and x from 1 to 10, that means 1 squared plus 2 raised to power 2 until the last item is 10 raised to power 2. Okay, that is the summation. We introduced arithmetic and geometric sequences, as well as the series. And we talked about finite geometric series. Finally, we gave you 2 applications of the series. That's all for this lecture. Thanks for watching.